Here I use a example on the textbook to show complicated flow chart. In the class, we will use a simple example to go through the flow charts, but the textbook actually has this example as the first example in the chapter. I'm gonna read it. It's very long. It's very complicated. It's actually intimidating. But the first thing when you see such a long description of a process, do not panic. I think that is the first thing that you need to learn to achieve this, okay? So do not panic. And to be honest with you, this is the first time I teach this class, and this is the first time to see this type of paragraph. I myself does not work on these petrochemical processes. I was a little bit intimidated at the first beginning when I read this. It's really long and a lot of chemical names. But once you stop panicking and you are just focusing on the content, then you already got like 60% of it, okay? So I'm gonna read it and I'll just replace some complicated words with the simpler words. The catalytic dehydrogenation of propane. Dehydrogenation of a propane, it is just a reaction, a catalytic dehydrogenation of a propane. So I can say the first reaction is carried out in a continuous packed bed reactor in a reactor. Okay, the reaction one is carried out in a reactor. And 1,000 of kilomole per hour of the pure propane. So this is the first material that we deal with. So if I say, if I call the propane as A, then I say 1,000 kilogram per hour of A, right? Of A is preheated and then to a temperature of 670 C before it passes into the reactor. Okay, so this is the same reactor I said in the reactor. So I now know the first step, I have something like that. Okay, so I would have a reactor. And then if you are more detail oriented, you can even say the first reactor is a packed bagged reactor. So you can just call it reactor, doesn't matter. And then what it goes in propane. That is the A propane, right? Goes into it. And then if you want to say it is actually some conditions, it is 1,000 kilogram per hour. And it is at 670 C. I don't even know if these numbers are needed because this is just a statement of the flow chart, doesn't ask us to calculate anything. So that is the first step. And then the reactor effluent gas. So after reactor, what is leaving the reactor is the effluent flow, right? It has gas, it is a gas, which includes propane, that is A is a propane. And propylene, methane, and hydrogen. Why not? I just call B, C, D. Why not? So if I say B is the propylene, and then C is methane, and then D is hydrogen, right? So I use this A, B, C, D here. And then these four gases as a mixture is cooled from 800 C to 110 C. So it doesn't say what is used to cool, but it doesn't matter. So I'm gonna just assume there is a chiller. Assume there is a chiller. And then originally it is at 800 C. And after that, it is at 110 C. And however, in the chiller, nothing happened except for the temperature change. So it is still ABCD, okay? ABCD, the four gases. And then after it's changed to 110 C, it is fed to a absorber tower. So next step, it will have a absorber tower. So it is a absorber tower. It doesn't matter, absorption you can say tower absorption step. And then inside this tower, what the process is, the propane and the propylene are dissolved in the oil. So somehow this tower has oil in it. So let me have some space, right? Because absorption tower, I just call ABS. And then somehow it has oil in it. I don't know if the oil is actually feeding to it or actually it is inside the tower preloaded with oil, right? So that's something I don't know. So I'm not doing this right now. I'll see how this description tells us. And then these two things will dissolve in the oil. And then this oil will go to some else place. Okay, so now I know inside the oil, if I say this is the oil, inside the oil, it will have propane and the propylene will dissolve. So A and B will be dissolved, right? And then assume C and D should go somewhere else place, or C and D will be accumulated inside this tower. And then if that's the case, then it has to be a batch process because C and D will accumulate. Eventually, you will have to stop the operation and open up this absorption tower and clean the C and D. So the possibility or the probability of having this type of batch process in a continuous operation flow is low. It's not very probable. So I can assume C and D is also leaving the absorption tower, but it doesn't really matter. So this is not described in the description, so may or may not be correct. So if that's the case, why not let me do this way? Why not let me use a different color or different line? Say I use a dash line to say C and D is probably also discharged from the absorb tower. And then this oil with the propane and the propane go into a stripping tower. Okay, go to a stripping tower. So this gotta go to a stripping tower. And then inside the stripping tower, it is heated and releasing the dissolved gases. That is the two gases that has been dissolved, the propane and propylene. So it is a stripping process to release the A and the B, okay? So I don't know if actually it releases here A and B together or separate. I'm gonna read it again, read it continuously read. These gases are recompressed and sent to a distillation column. Okay, so these two gases actually together are released to a distillation column. So this will be the distillation column. And then it's sent to a distillation column in which the propane and the propylene are separated. Oh, I see. So inside, using this distillation column to separate them, so these two will be separated. So I would imagine one would be A and one would be B. So this will be A and this will be B. It doesn't really matter which one is which one. And then the propane, that is A is recycled back to join the feed to the reactor preheater. Oh, okay. So the reactor is the first one, the reactor. This is what we have, the PBR reactor. And it has a preheater here. So I run out of space. So I'm gonna do this. I'm gonna wipe off this do not panic. I'm gonna put here. And apparently there's a preheater here. So of course you have the propane to be heated, but however here what it says is, I'm gonna just wipe out this notation because I have this here. A is propane, I have it here. So this actually will go back join recycled and then join the flow feed to the preheater, okay? And then the product stream from the distillation color contains 98% of propylene, okay? So B is actually the product. B is a product. It has 98 of propylene. This is a product. And then the recycle stream has 97% of A. 97% of the propane. The stripped oil is recycled back, recycled to the absorption tower. Oh, now I see. The stripping after the strip, A and B is discharged to distillation for separation, but the oil, or I can write this way, oil is recycled back to the absorption tower. So the absorption has oil. I don't know if you still remember, at that time, I didn't know if the oil is fed in or it was preloaded in the absorption tower. But now we know this oil is actually fed in, recycled from the stripping tower. Okay, so this is a flow chart of the entire description of this paragraph. And then as you can see, although if you read it at the first time and you don't know what it is about, so many chemical names, so many reactors, we don't even know what they are. And we naturally panicking, you know? So that will, once you are panicking, then your brain stopped. You will stop thinking and you will you will be frozen. So the key thing is actually do not panic. Do not panic. And if you read one thing and put one thing, and this will be your flow chart. Although this flow chart is much, much more complicated than what we normally see in our class. But nevertheless, if you have a patient and the basic concept of what flow chart is, then you should be able to handle any flow chart.